Skill 24, perpendiculars and angle bisectors. We're going to do number 11 here and prove the converse of the perpendicular bisector theorem. So first we're going to note that PA is equal to PB and M is the midpoint of AB. That is our given. Okay, so we can do two things here. We can start with definition of midpoint and definition of equal lengths or congruent lengths. So we have segment PA is congruent to segment PB by the definition of congruent segments. We also have AM is congruent to BM by definition of midpoint. So if we look at it this way, what we're trying to show is that the line that is from P to M is a perpendicular bisector. That is our goal. So if we can prove that these two triangles are congruent, then we can say something about those angles. So that's what I'm going to do. So I have a side and a side and a side and a side. So if I can get an included side that is congruent to the other, then I can have congruent triangles. So what I'm looking at here is a isosceles triangle right there. Since that is an isosceles triangle, what I can do is I can say that the angles, the base angles, are going to be congruent. So that's what I'm going to do next. I'm going to do those two steps. So step 4 is triangle APB is an isosceles triangle by definition of isosceles triangle. Now, since it's an isosceles triangle, we can use the isosceles triangle theorem. So angle A is congruent to angle B by the isosceles triangle theorem. Now what I have is a side, another angle, and then another side. So by side, angle, side, side, angle, side, I have two triangles that are congruent. So I have triangle AMP is congruent to triangle BMP by the side, angle, side postulate. Okay, so since that's the case, I can take it a step further, and I can say that this angle here, AMB, and this angle here, BMP, are congruent by corresponding parts. So that's my next step, to say angle AMP is congruent to angle BMP by the corresponding parts of congruent triangles. Okay, so now I should say something that these two angles form a linear pair, so they are supplementary. So that is my next step. What I want to say is that those two angles are 90 degrees. So angle AMP and angle BMP are supplementary by the linear pair postulate. So from there, because they are congruent and supplementary, I can say that they are 90 degrees. So now I know that these are actually right angles. Okay, so they're right angles, and M is the midpoint because BM and AM are the same. So they are a bisector, that M is a bisector and it is a perpendicular bisector. So that wraps up our proof. Say PM is the perpendicular bisector of segment AB by the definition of perpendicular bisector. And that's it. We're done. Number 12, prove the angle bisector theorem. So the angle bisector theorem says that if ray QS bisects angle PQR, and we know that segment SP is perpendicular to segment, or to ray QP, and also segment SR is perpendicular to ray QR. We know all of those things, and what we were trying to prove is that PS is the same length as RS. So the first thing I'm going to do is mark what I know, which I know SP is perpendicular to QP, and I know QS bisects PQR. So I know there's the bisecting part, and the perpendicular part. So because those are both definitions in geometry, that's where I'm going to start my proof. So I would say that by the definition of perpendicular, angle QPS and angle QRS are right angles. So I can say that these two are right angles because of that perpendicular part. And then we're going to do something with bisect. So I'm going to say that angle PQS is congruent to angle RQS, and that's by definition of bisect. So now I have a right angle and I have another angle, and it looks to me like I have two triangles. So I'm going to try to prove the triangles are congruent from that information. So the first thing I need to do is I need to actually say that those two right angles are congruent. So I say angle QPS is congruent to angle RQRS by the congruence of right angles theorem. So I would mark this angle is congruent to this angle. So now I have angle and angle. So if I could just get a side either included or on either side of them, then I can say that they are congruent triangles. Well, so now I'm going to look at my picture and I see this QS is part of both triangles. So I'm going to use that with my reflexive property. So step 5, segment QS is congruent to segment QS by the reflexive property. And then I should be able to quickly notice that I have angle, angle, side. Angle, angle, side of my triangles. So because of that, I can say the two triangles are congruent. So triangle QPS is congruent to triangle QRS by the angle, angle, side theorem. Well, if we know the two triangles are congruent, then we know that any corresponding sides must also be congruent. So since RS and PS are corresponding sides, we can say those sides are congruent to each other. Therefore, we have segment PS is congruent to segment RS by corresponding parts of congruent triangles going to be congruent to each other. Now the last thing we have to do is actually state that the lengths are equal to each other, because that's our goal to try to prove. So we actually have one more step, and that would be that PS is equal to RS, and that is by definition of congruent segments, going from congruent segments to equal segment lengths. So those are your notes over Skill 24, Perpendiculars and Angle Bisectors. Summarize your notes. Make sure these make sense. Go through some practice, the rest of your practice problems, and then you should be ready for the quiz over this material.